Hi everyone and welcome back to Fundamentals of Engineering with Farhad. In this example, we have an interesting problem in a combination of a spring and a cantilever beam in mechanics of materials. We want to solve it with the consistency of deformations. So in this example, we are provided with a cantilever beam attached to a spring, and the spring is fixed on the ground with the stiffness of 3EI over 2L cubed, and cantilever beam handles a distributed load of W. We want to calculate the force in a spring in this combination. So in such problem, we can dissect our problem into two parts, the beam part and also the spring part. And the key to this problem, and the same Fs with opposite direction applies to beam and spring. So if beam pushes the spring down by the force of Fs, which creates in develop in a spring, the same force based of Newton's law applies in opposite direction to the beam. And they are the key to this problem is delta B1 and delta B sub 2 are equal to each other, and they are also equal to deformation at point B. So delta B sub 1 is equal to delta B sub 2 and is equal to the deflection or downward movement of point B of the entire unit. So that's the key to our problem. That's why we call it consistency of deformation. It just says delta B1 is equal to delta B2, and that's exactly the downward movement of point B in this problem. So if we want to calculate the force in a spring F sub S, we will dissect our problem. Now let's delta B1 itself dissect to two parts. The first part is the effect of the distributed load plus, which we know that we call that delta 1, and that's WL to the 4 over 8 EI. We already calculate this beam, this cantilever beam with cantilever method with different approach. I will provide you with the link to know how to get delta 1 due to distributed load of W on a cantilever beam. That's WL to the force over 8 EI downward. And the other part is the same cantilever beam, but this time handling a upward force due to force of spring. And we also calculate this deflection as well, but in a downward position. But the amount of that, that's PL cubed over 3I, replace P by force of spring over here. So I will provide you with the link for also a cantilever beam with a concentrated load at its center to see how to calculate that. And the other half is the spring itself. So we call that delta B2. There is a stiffness for our spring, and there is a force of a spring which we are going to calculate it. And if K sub S stiffness of the spring is provided in problem statement to be 3EI over 2L cubed, and delta B definitely in a spring is F over K. Delta, we know that from physics, that's F is equal to K delta for a spring system. So delta is simply equal to F times K, force over the stiffness, and the consistency of deformation. It just says delta B1 is equal to delta B2. So this is delta B1 in a beam system and delta B2 in a spring, and delta B1 due to consistency of deformation should be equal to delta B2. And if that's the case, the delta B1 is coming from subtraction of delta 1 minus upward downward delta 1 minus upward delta 2, which we talked about it previously, and that should be equal, and all these are delta B1, and that should be equal to Fs over Ks, which is delta B2, and that's again the consistency of deformations. So if we know what the stiffness of the spring is, and based of consistency of deformation, delta B1 is equal to delta B2, and if you just replace Ks by its parametric value, it gives you Fs times 2L cubed over 3EI in the second part. And if you simplify the equation, take the WL to the 4 over EI in the first part, add this part to the second part, and that gives us 3FSL cubed over 3EI. And it just says Fs is equal to WL over 8. That's our force in a spring which we are looking for. You can see how easily we solve this uh, problem, statically indeterminate problem, just with the consistency of deformation. So as soon as we have Fs, which is WL over 8, we can also calculate delta B, which is Fs, force of spring divided by stiffness of the spring, and it just gives us WL over 8 over the stiffness, which is 3EI over 2L cubed, and it just gives us delta B is WL to the 4 over 12EI. So for such problem, we can easily see Fs is WL over 8 and delta B is WL to the fourth over 12 EI for displacement at point B. Thank you. We will solve this problem also with another approach 2, which is fix and release method in next video. Thank you.